All right, the question says, in this question, we're to take pi to be equal to 22/7. We said that the diagram below, not drawn to scale, shows the cross-section of a circular metal disc, 21 millimeters, a square hole with sides 6 millimeters is located at the center of the disc. We're to calculate the circumference of the disc. Well, that shouldn't be difficult. Circumference C is equal to 2 pi r. And of course, everybody knows if you can't get all of the marks, you should at least try to get some of the marks. This now is 2 times 22/7 multiplied by the radius, which is 21. 7 go into 21 goes 3 times. And so this is 2 times 22, which is 44 times 3. And the answer is 132 centimeters. So the circumference of the disc is 132 centimeters.
So in a millimeter.
Is millimeter, thank you. Trying to get the robot to come out. But this thing, when it's ready, it does be of mud. All right, so 132 millimeters. All right, it says we're to calculate the area in millimeters square of the cross-section of the disc. So the cross-section is actually a square, but is a circle, but there's a square hole. So if you're going to calculate the area of the cross-section, it's going to be the area of the circle minus the area of the square. So the area of the cross-section area is equal to pi r squared minus L squared, where L is the area of the, L squared is the area of the square at the center. This is 22/7 times 21/1 times 21/1 minus 6 times 6. This goes into this 3 times. So this is 44, sorry, not 44. It is 66 times 21. So this is 66 times 21. So the area of the circle is 1,386 minus the area of the square, which is 36. So the area of the cross section is 1,350, and this is millimeters square. All right, let's go to the next part of the question. It says, given that the thickness of the disc is 2 millimeters, we're to calculate the maximum number of discs that can be constructed from 1,000 centimeters cube, from 1,000 centimeter cube of available metal. All right, and he helped us out a bit. He said 1 centimeters cube is equal to 1,000 millimeter cube. I find that he's very generous. I don't think he should have given you that, but he did. So far, what we have is something looking like this. I'm gonna try and just do a little sketch of it. It's a very thin disc, and in the middle of it, is a square hole, something like that. We already calculated the area of the cross section, 1,350, and the thickness of the disc is 2 millimeters. Now, the volume, because it's a solid shape with a uniform cross-section, the volume is equal to A times H. The area is 1,350 multiplied by H, which is the thickness, which is 2. So this is 2,700 millimeters cube. Now, they have 1,000 centimeters cube of metal. So we're looking at the metal. And the volume is equal to 1,000 centimeters cube, but 1 centimeter cube is equal to 1,000 millimeter cube. So this will be 1,000 times 1,000, which is 1 million millimeters cube. So 1,000 centimeters cube is 1,000 centimeters cube is 1 million millimeter cube. Here's the question. If I have 1 million millimeters cube of metal available and one disc requires 2,700 millimeters cube, how do I determine the number of discs I can get? What must I do?
Divide.
Anybody?
Divide.
Very good. I must divide number of discs would be equal to 1 million divided by 2,700. All right. So we're going to give our answer to the nearest whole number. Divided by 2,700. And my answer, the answer I got is approximately 370 discs. All right. Let's move on to the next part of the question. So the next part of the question says, a globe is a scaled spherical representation of the Earth. The actual length of the equator, LL, is 40,000 kilometers and is represented on the globe by a piece of string of length 160 centimeters. So 160 centimeters is representing 40,000 kilometers. It says, what length of string would represent an actual distance of 500 kilometers? What length of string would represent an actual distance of 500 kilometers? So this is map. Whenever you have a map, this is what 160 centimeters is on the map or the globe, and 40 kilometers is actual. So map to the left, actual to the right. Now, this actual distance is 500 kilometers. I don't know what length string is representing it on the globe, so I call that length of string X. Then I'm going to cross multiply. So this is 40,000 X is equal to
80,000.
I'm wondering if this is a good idea, or should I have converted every single thing to centimeters? Let's proceed. This is 1,160 times 500. All right, then I'm going to divide both sides by 40,000. All right, let's go 3 zeros, answer the 3 zeros. So now I have X is equal to 16 times 5 divided by 40. All right. This is 2 times 8 times 5 times 5. 8 times 5 is 40, so that cancels 40. X is equal to 2 centimeters. Did anybody get 2 centimeters? That's
Yes,
what
sir.
I'm thinking. X is 2 centimeters. All right. Then it says, the last part of the question, it says the distance between Palmyra, P, and Quintet, Q, is represented on the globe by a string of length 25 centimeters. Calculate the value of PQ, the actual distance in kilometers between P and Q. All right, so the distance on the map is 25 centimeters. So if I want, let's bring back my scale. 160 is representing 40,000. 160 is representing 40,000 kilometers. This is 25 centimeters. I don't know the actual, so I call it X. This is the ritual I would go through to find the answer. This is 160X is equal to 25 times 40,000. Divide both sides by 160. So therefore, X would be equal to 0 cancels 0. This is what? 4,000. I can divide it by 8. I think I would get 500. 8 into this is 2. Sorry, let's use the calculator. Stress myself. So this is 25 times 4,000 divided by 16. The actual distance is, or the distance of 25 centimeters on the globe. Sorry, on the globe. On the globe is 6,250, or is actually 6,250 kilometers. Did anybody get this? 6,250 kilometers. All right.